this one is a pretty long section. What we've done so far is we looked at, if you're given a function, being able to tell whether it's odd, even, or neither without a calculator. And now we're going to look at just some basic information. A lot of this stuff is pre-calculus information right here. So basically the idea, and this is real straightforward and real simple, is if you're looking at a function and you're looking from left to right, you read from left to right, if the function values are getting bigger, the y values are getting bigger, we say we're increasing. So like in this situation here, from there to there, we name that with x values. Whenever you name intervals where something's increasing, you look at x values. Okay, the y values are getting bigger. Now what happens there, y stays the same. Maybe we call that constant because y doesn't change. And then it's going to increase again because y's are getting bigger. And then finally it decreases like that. Okay, now that's real straightforward to students. Just always remember to read left to right, and then you name your intervals with x values. You're going to use interval notation typically, and you would go from left to right when you do that, starting with x values like that. Okay? The other thing that we do that is worth writing on here is we use open, or actually I've already got this on here, we use open intervals on these things, and that means that you'll always have parentheses in your interval when you're naming where something increases and decreases, because at the end of that, then it might be changing from something else then, okay? So there's just some basic examples. This one, what you would say here, and I'm going to have you just kind of write the interval on this one, we would say that you're increasing on, and we'd start at 0, but we'd have an open interval like that, and then it would go to infinity like that, okay? And then decreasing on this one, we would say 0 to infinity. That's just from left to right, the y values are getting smaller, okay? Constant function, well, you don't really, on this one, you would do the same thing. You would say it's constant, and then you would say from 0 to infinity like that. So again, what you're always doing is you're naming x value. Starts at 0, goes on forever like that, okay? So we want to just look at some of these for a few minutes. And I want to go over a graph. I think I'm going to do this first graph and then let you do 12 yourself and see if you caught on to what I'm talking about here. Okay, so first of all, we're going to use open intervals. So increasing, there's actually two places this is increasing, and I'll just highlight those in yellow like that. Okay, and again, what you do is you use x values. So that looks like that is, boy, I can't see that very good. Is that -2, or do you think it's like -2.5? I don't got very good eyes, okay? I'm thinking maybe -2.5. What do you think?
Yeah, 2.5.
That's what I'm thinking. Straight down like that, okay? So let's say that's -2.5, okay? And then, of course, that's 0. And then that looks like, so I'm looking at the x value. That looks like 2.5 like that. That right there looks like 5. And that right there looks like -5. So what you would say for the function increasing, what you would say is from these x values, you would say from -2.5 to 0, like that. And again, they're open intervals. And then what we'd do is you say union to get the next one. So the next one would be 2.5 up to 5 like that. Okay, so use open intervals and just name them from left to right. Okay, decreasing would be these. You're going, it's kind of like you're on a roller coaster and you're going downhill. So the things I highlighted in blue are decreasing. Okay, so decreasing, what would you say? You would say from where to where? -5 to -2.5, again with parentheses, and then the other place would be where? 0 to 2.5 like that. Okay, so that's real straightforward how you name that. Is it constant ever?
No.
What does constant mean? It just means it's like level for a certain interval like that. So there's no place where that one is constant. So we'll just say it's never constant like that. Okay, now these points right here are kind of neutral. You know, whenever it changes from increasing to decreasing, we don't include that in the interval. We don't say that's a part of increasing or decreasing. So always use open intervals when you do this then, okay? All right, go ahead. I want you guys to just fill out the next one. Now this one is supposed to go on forever. So if you'll just put 2 arrows at the end of that, and then just take a minute to see if you can name what those intervals are. Remember, it's x values, left to right. Open intervals is what you do, okay? So I'll just give you a minute to do that, and that's about all we're going to talk about on this. This is a big deal in calculus. If you take calculus, you talk a lot about how functions are increasing and decreasing and how to figure that out with calculus methods. So we just try to get you introduced to that idea. So constant, where is this thing constant? Where's it level? What did you put? Where to where? Negative infinity to where? Negative 2, and then where? 0 to 2. Good. Okay, so the two that I got in yellow are where it's going to be constant. So we'd say, whoops, there's constant. Negative infinity to negative 2, and then union 0 to 2 like that. Okay, how about increasing? What did you put? Negative 2 to 0. That'd be the part I have in blue. The y values are getting bigger. So open interval, negative 2 to 0. And then how about decreasing? 2 to infinity. Okay, so that's from there on out. So you'd have 2 to infinity like that. Okay, use x values. Name those things from left to right. Everybody got that? Okay, that shouldn't be too much to that. We're not going to get too technical about that in this class. We just kind of get the rough idea. Okay, all right. Now we want to look at the idea of what a local maximum and a local minimum is. Again, this is pre-calc stuff, really. So basically the way I look at this is the way I like to look at a local minimum without this definition so much is basically what's going to happen is your function's going to increase and then decrease. So you can write this if you want to. So a local minimum, you can think of this, to me the simplest way to think of this is a local minimum. It just means the graph decreases, then changes directions on the other side of that minimum and starts increasing like that. Okay, so it can't be an endpoint. There's got to be something going to the left of it and something going to the right like that. Then if you have a local maximum, well, that's just the opposite situation. It just means that your function's going to increase. Okay, then it changes directions and then it starts decreasing. Okay, so you're never going to have an endpoint, and I think I wrote that on your notes. So a local maximum is just a place where to the left it's increasing, then it starts decreasing. That's like the top end of a roller coaster. That's another local max right there. Increases, decreases. Okay. Local minimum's opposite. That's a low point, so it decreases, increases, decreases, increases like that. If you have an endpoint, you don't consider that to be a local maximum or a local min because it would have to be doing something to the right of it, say. So think of it as something's going on before and something's going on after. Does that make sense? Okay, it's real simple, the idea. It's just a high point and a low point. But again, the key thing on this is endpoints, you exclude those things, okay? So you have to have that. And you have to be defined at that point. We'll look at some examples. I'll show you kind of what happens if you're undefined. We'll look at that in just a minute, okay? So the other thing is textbooks kind of use this interchangeably, and I do sometimes too. Sometimes you'll hear it called a local minimum. Sometimes you'll hear it called a relative minimum or maximum. They mean the same thing. What it just means is in some small area in the graph, you're coming to a high point or a low point. Just think of it that way, okay? Then what we have is absolute minima and absolute maximum. Sometimes those are called global maximums and global minimums. That just means an absolute minimum would be the absolute lowest value of y that the graph ever hits. So that's the smallest y value. Absolute maximum would just be the very largest y value that you ever hit, okay? You actually don't have to have an absolute max or min, but oftentimes you do, okay? So that's how that goes. So notice on this diagram, this would be a local maximum because the graph is increasing, changes directions, and then decreases, okay? This one is a global max. How come? Because it's the absolute highest point that the graph ever hits. So we say global or we say absolute. Okay, this one would be a local minimum. And again, what happens on this is I think I did that, yeah, like this. This would go decrease and then increase like that. And then that's global because why? It's the lowest value that ever hits. Okay, does that make sense? Okay, now see, this is also, these two things are local minimums. They're both local minimums because the graph increases, decreases, increases. but that's the global or the absolute just because it's lower than that one is. Does that make sense? Okay. And then when you have endpoints can never be relative local max or min, but they can be absolute. So you could, if you had a point that went like that, there was an endpoint, well then that could be an absolute max. Okay, so endpoints can be global, but they can't be relative. Okay, that's a little picky details of that then. Okay, so generally when you name extrema, and textbooks do this differently, a lot of times, most of the time I just have you name it as a point. You just locate the point, tell me whether it's a max or min. Sometimes the textbook might want you to give a y value. Okay, those are kind of typical ways. They're kind of interchangeable. Most of the time I'm just going to give them as a point. Okay, so let's look at a couple of these things then on this next page. So this graph you're supposed to be going on forever. Okay, like that. Okay, tell me how many local minimum you see. 2. Okay, there's 2. Okay, and again, that's just a place where the function decreases and increases. There's another one, decreases and increases. We're just going to write these as points. So I'm going to write that as -2, 0 would be the first one. And then 2, 0 like that. Use a semicolon to separate. Don't use a union, because you only use that if you're doing interval C. Okay, you're just listing what they are. How many local maximums are there? There's 1. Okay, and that local maximum occurs here. That's just a place where the function increased, hit a high point, and then went down. Okay, like that. So we'd just say that's the point, 0, 1, like that. Okay, what if I ask for this? If I said absolute max on this, what would you conclude about that? Does that graph ever hit an absolute high point, or does it just get higher forever? It's higher forever, right? Okay, that's what those arrows are saying. So you would not have an absolute max on that, see? Okay. Would you have an absolute min? Yeah, you would actually have 2 of them. These right here would also, those 2 points right there would also be absolute. It's write and talk sometimes at the same time. That'd also be an absolute min, okay? So you don't have an absolute max on that, but you do have 2 absolute mins because they have the same y value, 0. That's the idea, okay? Okay, so let's see. I'm going to have you look at the next one. And I've already got the points on there, and just write out what you think the local min are and what the local maximum are. And while we're at it, I want you to just kind of think about what you think the absolute max is, if you got one, and what the absolute min is right there. That time I gave you the point, so there's no guesswork on it. And in exams, these are kind of things that we do that are fairly straightforward that you want to know how to do. Just taking a graph and then identifying these pieces of it. Increase, decrease, local max, min, absolute max, min, stuff like that. Then we'll kind of get into the next thing we're going to do is do a little bit of stuff with our calculator. So how many local minimums does this graph have? There are 2. Okay, the 2 local minimums are here. Those are the low points. Again, the graph is decreasing then increasing, and you just name them as points. So we'll just say -2.5, -3.3, and then 5, -2.5 like that. How many absolute maximums does it have? It has 2 also, right? Okay, those are places where the graph increases, then decreases. So it looks like your absolute max are going to be -8.5, and if I can read that right, 2.2, 3.9. Okay, does this have an absolute max or an absolute min? No. Okay, I mean, the way it's written, that's intended to be an arrow. Okay, so unless that's got like a solid dot on it, you just assume that that goes on forever. So actually, you would not have an absolute max or min because it doesn't reach a absolute high point or absolute low point. Okay, all right, everybody good there? Okay, these are some of the simpler concepts to learn how to do. Now, if you're going to take calculus, you study this a lot more in depth, but you just want to get the idea of what those things are. Okay. All right, next thing, if you will get your calculator out, please. We need to go through a couple of things on the calculator in this section. When you get into your exam 1 next week, there are some calculator problems on this. This is something that's pretty typical that you want to know how to do. So what this one is saying, and we have to use the calculator to do this, is we're going to look at this function, and we're going to figure out what its maximum height is. If you're a calculus student, you can actually do this with calculus, and you don't have to worry about graphing or anything. So what we want to do, and if you'll just do this with me, you're going to need to know how to do this when we get into your first exam, and we'll do this from time to time. What you want to do is just put in y1, and you want to put this in. You're going to have to use x's, so you have negative 16x the second plus 60x plus 8. I want to go ahead and get that put in. So let's say we have negative 16x the second plus 60x plus 8. Now, I don't give you a viewing window on this. That's a part of what you're expected to know how to do. So what happens on this, what I recommend is when you do your window, I'm going to go ahead and put my window button on here. Let's just kind of fill in what we have. I'm just going to put x min, x max. Now, x min has to be 0. And the reason is because we're talking about time. In this problem, t is time. You're basically like shooting a ball or something like a projectile, and it's going to go through a parabolic path, and it's eventually going to reach the ground. So we'll have to figure out what that is and what the x scale is. Okay, now the y's is the same way. Okay, the smallest y needs to be 0 because that is a height, so we're not going to have negative heights. And then we need to figure out what the y max is and what the y min is, like this. So here's what I do, and this is what I recommend you do, is just look at your table and look at some of the values. So if you go second graph, then that will look at a table of values for you. And all you got to do is just kind of look at what's happening starting at 0. And look at how these y values get bigger. Like there's 0, 8. The y values are getting bigger. Now, eventually, they start going down again. And once we get into those negative numbers, it doesn't have any meaning. Okay? So we want y to be positive. So if you were to look at what I have, I think, what's the biggest one? Is that a 64 on there? So you might want to go up to 80 or something like that. So let's try to do this kind of like this. Let's do, and this is up to you, but 80 is a pretty logical thing, and then we could scale by 10 on the y-axis. And then if you look at that, it looks like probably all we need to go maybe up to 4, and then we're pretty good. So if I just look at this table, that kind of tells me sensible values I can do. Okay, so what I'm going to do is go ahead and put that in. You can go ahead and do that. We're going to go x is 0 to 4, scale of 1. Y, we're going to go 0 to 80, scale of 10. And then you can go ahead and graph it, and what you'll see on this is you should see a parabola, and you should see the high point. The point on this is you want to see what that high point is. So that's a good viewing window right there. Does that make sense to everybody how I figured that out? Okay, because I don't tell you a window. You have to figure that out. Just look at your table of values, and that'll help you reason that out then. Okay? All right, so here's what we want to do then is what I want you to do is just on your notes, just draw a really rough graph. And if you're doing this on an exam, there's certain things that you have to have on here. You would want to label that as time, and you would want to label the y-axis as height. Okay, and then just do your scale. So we'll just go 1, 2, 3, 4. You need to always label those so that I know what they represent. And then we'll just go 10, 20, 30, 40, 50. You don't have to label all of them, but just enough so that I pretty clearly see what that is. Okay, so that's how that goes. And then this is, the time is in seconds. And then the height is going to be in feet. So what you want to do when you're drawing a graph like this that has some sort of a meaning, is get that stuff written out like that. And then what you can do is just get points. And you can trace to get points. A lot of times on an exam, I might say label 3 or 4 points. So this is what I want you to do. If you type trace 0, so if you just trace it 0, that'll give you a 0.08. Okay, and when I'm having you graph on exams, I like you to label what stuff is because I want it to be accurate. Then you could trace it 1. Usually you only have to type the trace button 1 time. So that would give 52. Just kind of estimate where it is and then label that point like that. And then we'll trace it at 2. So it looks like 264 is a point. So just kind of estimate where that is. Okay, and then let's trace it 3. So that will be 44. Okay, and then that's probably good enough. So this is what I usually kind of have you do, is just kind of label some of the points like that. Okay, now what we're going to do is we're going to find the maximum. And if you have never done this before, I would recommend that you write down the keystrokes, because when you do the maximum, you don't go through and estimate it. You get it done exactly. So if you need to write this down, do this. What you do is you go, the keystrokes are secant, trace, and what that does is that opens up a menu for you. So you want to go secant, then your trace button, and then you'll notice that you have option 4. We're trying to find a maximum on this. So you do option 4 max, and then you have to press enter. Now you can just press 4 and it'll take you to that automatically. What it's going to ask for is a left bound. So you got to use your left cursor key to move that cursor so it's a little bit to the left of where that maximum is. Okay, then when you get to a point where you're confident that you know you're at the left of that, then press enter. So you want to do like what's called a left bound, press enter. Okay, now it's going to ask for a right bound, so just use your right cursor key, get a little bit to the right of where that maximum is, just a little bit's all it takes. Press enter again. Okay, then it's going to say guess, so you just press enter again. So right bound, press enter after you get it. And then guess, just press enter again. Write the keystrokes down if you need to. And then it'll tell you what it is. You're going to know you're doing this right too, because what it'll do is it'll be blinking on that maximum, and you can tell that's at the maximum. So what we would say then is that point, that max, is giving us what looks like the point 1.8750012, 64.25 like that. Okay, and that's how that goes. Everybody understand and follow what I was doing on that okay? Is everybody's calculator working okay? Okay, yours isn't? Okay, is it not graphing? You got something? Go ahead.
How did you get all those points right there?
These points that I wrote down?
Yeah.
Yeah, okay, let me show you what I did. So did you get your graph okay?
I think so.
Okay, you got a parabola going like that and you have the same window. What you can do is you can trace. So if you type your trace button, then just put in the X value. Like I started at 0, so if you trace 0, press enter, that's how I got that 0.08. So that's a real quick way to get the Y value for a certain X. Okay, you have a trace button on there, right? Yeah, it's right above, right there. So type that first. Now if it doesn't work, I'd have to look at your calculator and see if there's something wrong with it.
You go all the way down to 0?
Yeah, just go trace and then 0 and then press enter. And what will happen is the cursor will blink on that point, then it should display that you have 0.8. Is that working?
Yeah.
Okay. And usually you only have to type trace one time. So if you type 1 now, after you've typed trace, then notice that's given 152, and that's where I'm getting those values. Okay, you got it?
Yeah.
The other thing you can do is this. You can go secant graph and get your table of values up, and see if you do that, you can get the points that way too. It's good to know how to do it both, so you can look up your table like that. Guys, you're working okay now? Okay. A lot of times what students have is they have that plot turned on. Make sure you don't have your plots turned on, because you only do that if you're doing like scatter plots and statistical graphs. So those things just stay off for what we're doing now, okay? All right, so that we got the max. Everybody follow how I got the max then? Okay, that's something that you want to know how to do. And then the question on this is what is the maximum height? Well, which one of these numbers is the height? Is it the 1.8 or the 64? 64. Okay, that's the height. What's that? That's the time. So that's how long it takes to reach a maximum height. So then the answer to this problem, we would just say max height would just be equal to, and we round that to the hundredth is 2 decimals, that's 64.25 feet like that. Okay. Now that's something you're going to do from time to time in the class, is use your calculator to find maximums, minimums, and different things like that. All right, everybody with me okay? Okay. All right, very good. Okay. Now I want to look at these two problems. There's a few little picky details of these. And with number 17, first of all, we're looking for absolute minimum. So look at the graph I gave you. Does that ever reach an absolute low point? Yeah, okay. This point right here, 1, 2. Okay. So you could write the answer as a point 1, 2 if you want to. Sometimes, like my math lab, they will usually direct you how you want that. They may say write as a point. If they want a y value, just say y equals 2, like that. Okay, whoops. Okay, yeah, that's absolute minimum. Now this one I think is supposed to be absolute maximum. That's what that means, okay? So look carefully at my graph. Does that have an absolute largest y value? Yes or no?
No.
No. How come?
Arrow.
Because of that arrow. That arrow is telling you that you're going up forever, so you do not have an absolute maximum on that then. Okay, how about a local minimum? What is a local minimum? It's a place where the function decreases, it's a low point, and then starts increasing. Do you have that? Yeah, where is that? The 0.12. See, that's also a local minimum. Okay? All right, local maximum. A local maximum means that you're going to increase, then decrease. Does that ever happen anywhere in the graph? Yes. Okay, it happens at the 0.35. So this right here, that point right there is a local max. Okay, for that reason, this point right here is a local minimum. Now, let's look at this one extra point right here. Okay, what does that bubble mean? It means you're undefined, okay? So, although the graph decreases and increases, that is not a local minimum because that y value is not defined. Okay, so that if you have an undefined place right there, that cannot be a local min or max. Okay, because it has to be a point and it has to have a defined y value. So that doesn't count. Okay, so this one is nothing. Okay, that's not a max and it's not a min. Does that make sense to everybody? Be careful about that. You got to be defined at that point. Okay, all right. So let's look at this next one here. Okay, absolute minimum. Look at the graph very carefully. Does this thing ever have an absolute lowest y value? No. How do you know no? Because there's a bubble there, right? Okay. See, this right here has a bubble there, so there's not a y value there. I probably shouldn't even put that 0.12, so there isn't one. Okay. How about an absolute maximum? Is there an absolute highest value of y? Same thing, okay? Now here's the thing you got to understand. Okay, right there, you may have a 0.6, 0.99999, etc., but you'll never hit 7. So you can never pinpoint that down to one value. So since there's a bubble there, that's why we would say that is not an absolute max, okay? All right, how about a local min? Does this have a local min?
No.
Okay, it's got to do what? It's got to decrease. It's got to increase, and that's got to be solid. Does that ever happen? No, so you don't have one. Okay, how about a local maximum? Local max means you're increasing, solid dot, decreasing. Does that ever happen? No, so you don't have one. So this doesn't have any of those things. Now, this thing right here, remember what we said about endpoints, is endpoints cannot be, they can never be local max or min. Okay, that's important. Those are just kind of little picky details you get in there. Okay, so that's kind of showing you about all the little different nuances of the problem that you encounter. Any questions about that? Okay, all right. Now, the next thing, you want to get your calculator out. So this is another thing I want you to get comfortable with doing. So let's say we're going to use the graph. We're going to find where it's increasing and decreasing. Okay, now this is another thing that's, typically on an exam, like an early exam, like, say, exam 1, I want you to know how to find maxims, mins, figure out where things are increasing and decreasing with your calculator. So do this along with me, and let's see if we've got this under control here. First thing you want to do is you want to put in the function. Okay, so you want to put in negative 0.3, then x to the third, and then plus 0.2. Let's see, that's x to the second. And then plus 4x, and then minus 5 like that. And now what I'm doing this time is I'm giving you an interval to graph this on. Okay, so this right here is going to give you a window to do this on. So when you do this, you want to do x min is -4 in your window. Then you want to do x max is 5, and then you could do x scale on that is equal to 1 like that. Okay, so you want to start like that. So I'm going to go ahead and put my window in and just go -4 to 5 since I gave you that viewing window. Now you got to figure out the y's. Now, a lot of times students will use this thing called zoom fit. If you go zoom fit, sometimes it works good, sometimes it doesn't work very well at all. So I would prefer you go through and just look at your table of values and reason out good values on there. Because there's a zoom in, zoom out. If you go all the way down the bottom on these, I think that has a zoom fit. You can always try that and see if that gives you anything, but that's not really what I'd prefer you to do. What I'd prefer you to do is go second graph, open up your table, and just kind of start looking at these values. Like if you look at this at -4, you're at 1.4. And notice the y values. The smallest y value I see is like -9.8. And then the biggest y value I see is somewhere like around 1.4. Okay, something like that. So for that reason, what would be logical to me on this would just be for your y minimum, you could try something like -10 or even smaller. Let's do something like maybe -15 just to be safe. And then for y max, you could do something like 2 or 3. Okay, as long as you got a good picture of it, that's all that matters. There's no one exact way to do that. So I'm going to go ahead and have you put it in the window like that. Go -4 to 5. And then for the y min, let's go -15. And then let's go up to like 3 or something like that. Okay, and then scale that by 1. Okay, so now put your do your graph, and then see if you can kind of visually see where there's some maxes and mins. Okay, so if you got everything set up the way I'm showing you, that's what you would have in that problem then. Okay, like that. Okay, so everybody with me on how you put that in and everything? Yeah, no, tell me. Everybody's calculator working okay? All right. So what we're going to do is we're going to figure out where it increases. So increasing would be, just visually, would be from there to there, right? But you need to figure out that value and that value. That's a local min, right? That's a local max. So what you need to do is just use the feature that I showed you to find what those 2 points are then, okay? So I'm going to slide this over here, put my graph over here for a second here, and show you what to do. So what you would do now is you would just repeat what we did on a previous problem. You go second trace, and I'm going to start by finding this minimum. So if you go to option 3 minimum, then you just press enter, and then what it's going to ask for is it's going to ask for a left bound. So if you got everything on there, just get a little bit to the left of where that is, then press enter. Usually on most of these calculators a line comes out, unless you have like the 83. Okay, then right bound, go a little bit to the right. Once you're to the right, press enter. Usually another line comes out. When it says guess, press enter again. And then we'll record what that is. So that point, and let's just round this to like 2 decimals. That's going to be like -1.897. So let's just say 90. And then -9.82. Okay, so that's what that minimum is. Now for the maximum, the local max, you just need to repeat the same thing. You go second trace. This time you go option 4 to get the maximum there. Then you do the same thing. You want to get a left bound. My calculator is kind of slow in doing this, so just get to the left of it somewhere. It doesn't have to be like super close to it. It can be even in there. Then right bound, we just need to get a little bit to the right of it. And then we'll record what we get. And you'll always know you're doing this right because it will blink on that and it'll tell you what that point is. Okay, so press enter when it says guess. And that is getting me, it looks like, 2.34 and then 1.611 like that. All right, is everybody with me there? Doing that okay? Okay. All right, so what you would do now is based on that is you would do these things. Now for a sketch, what I'll have you do here on just the sketch that I want you to do is this, and this is what I would want you to do like on a test, is, you know, go through and just do your sketch. So let's see, 1, 2, 3, 4. You always want to label kind of how things are going. Okay, and that's good enough. You don't have to put, 1, 2, 3, 4, 5. I know what you're talking about if you have that. And then, let's see, we went all the way up to, I guess, 3. And then you could even go like this if you wanted to. You could go down, you could go like -5. negative 10 or something like that if you want to. Then all I'm looking for is that you sketch. I might have you label 2 or 3 points. So what you could do on this then is, like this point right here, 1, 2, 3, 4, 5, you do have a point 0, negative 5. Then you could do your minimum if you want to. So that's negative 1.9. You can just sort of estimate that. And then you have a point kind of going through like that. Okay, and then you got an intercept there, and then you've got this maximum that you could label like this, but I generally like you to label a certain number of points, and I always tell you what to do on that. Okay, so that would be basically what your graph looks like if you draw a sketch kind of like that. Okay, the thing about it is I get students a lot of times in this class on tests, this is their graph. Okay, that's not a graph. Okay, that's like art. Okay, and it's like dull art too. It ain't you're not gonna sell any art like that. You got to label everything, right? Okay, so at least label points and get your scale. That's more like what I'm looking for is that then. Okay, all right. So now what we would do is when we write our intervals, the intervals would basically kind of go like this then. Okay, so it looks like if you look at the graph that we just drew, we would be decreasing 2 places, there and there. So if we go through and write decreasing, it looks like we would say negative infinity until we get to negative 1.90, and then union, then it would be this x value, which was, I think, 2.4, and then to infinity like that. Okay, I had those points written down on my graph, but I erased those. And then increasing is just going to be from this x value to that one, so that is negative 1.90 to 2.34 like that. Okay, so that's another thing I want you to be able to do is in addition to doing mins and maxes, use your calculator to figure out where things are increasing and decreasing, and that boils down to figuring out maxes and mins. Okay, everybody okay with what I just did? Okay, all right. So that's something you want to definitely know how to do. Okay. Okay, so let's see. I'm going to have you all on number 20, just give you a minute to put that in. Go ahead and put that in your calculator, do a sketch, and then figure out what the local max and min is like I just did on the previous problem, okay? So write that down if you need to, but you should have your hand out, and I'm going to shut this off for a second and then see if you can get that okay. And again, with this one, I want you to just go from negative 5 to 5. So for your X window, negative 5 to 5, but you'll need to figure out what a good Y window is then, okay? And then this kind of a problem, sometimes you have to kind of zoom on it a little bit when you do this, because I was starting my window kind of like this. So one of the things I did when I looked at my table of values on here, I noticed that at -5, that's the highest point it reaches, is like 1277 or 1220, or yeah, 1277. So I thought, well, let's go up to 1300, so that will get in there okay. And then the lowest values I was seeing was -3. That popped up several times like that. So one thing that you could kind of do on this, to me, to really see where the min and maxes are, one of the better ways to do this is probably just sort of zoom around one of those areas. Like if you did something like -10 and only made the max go up to like 50 or something. And if you did that, you wouldn't see the max, but you would be able to have a good viewing window around where those mins and maxes are. So I'm going to try just kind of to start a window like that. And again, I've got to see kind of how this goes. And see, that's a good viewing window for how the min and maxes go. Okay. And you wouldn't have to go all the way up to 1300. You could, just use the arrow and kind of show it from that point like that if you wanted to. So if you got that, you're going to have 2 local minimums. Then you'll have 1 local max like this. Now what I'm going to mainly do on this, I'm just going to put that graph there. You can sketch a graph, but then I'll go through and I'll go ahead and find the mins and maxes like this then. So if you do that window, then you should be able to get this okay. I'm just rounding those to like 2 decimals. So that's like one of my mins like that. And we'll do the maximum. So I got that for the max, and then we've got to get the other min. Okay, let's see. So all right, that's what I'm getting on that. So if you're doing that okay, then you can just round those off. That's what I ended up getting. Okay. All right, is that okay? Is everybody doing that okay? Any questions about how you do that? Okay. All right. Okay, so we got a little bit more that we need to finish up on this, and you can just write those on the answer blank if you want to. So the min is -0.57, -6.12. The other one I just rounded to like 3 and -3 because I think it had 2.99 in it. And then the local max would be 1.32, 5.64 like that. Okay. All right. Any questions? Okay. All right. Very good. Because you're going to do that quite a bit here and there throughout the semester. Okay. Let me go ahead and get this. The next thing we want to look at is I'm going to go ahead and look at one more like 21. 22 is a little bit different. So this is kind of another kind of thing that you want to know how to do. We did this before. So what I want you to do on this is just take your calculator and in Y1 put in -16x squared plus 440x, and then see if you can figure out how many seconds it takes for it to reach the maximum height, okay? So what I want you to do on this is just kind of do a rough sketch. You've got to use your calculator on that. You want to label this as time in seconds. And you want to do this like if you're going to test, label everything. And you'll have to figure out how to do the time and then how to do the height like that. So go ahead and put it in and see what you can conclude. And then the height on this looks like it is, does it say anywhere? Yeah, it doesn't really say, does it? We'll just assume that's feet, because I don't see it written in there anywhere. So try that and see if you can do that okay. And again, when you figure out your window, look at your table of values, and that'll kind of help you see how you should have something that is looks like it's probably going up, and then it'll go down, so it'll be some sort of a parabola when you put that in. If you begin to look at your table, see, you'll see this one is going to go up for a long time, okay? And in that case, you don't want to scroll forever. Just try to pick something up, because I can see on there that it looks like the Y's are going to get bigger for a while, then they're going to get smaller. So it looks to me like if you're going up to maybe 3,500 or 4,000 like that, you'll have everything you need to have. And then it looks like if you take that out all the way out to about around 27, 28, that's when you start getting negative numbers like that. Okay, so if you look at that table of values, that's what I'm wanting you to be able to use to figure out what a good scale is on this. So I'd probably do this one kind of like this on the window. I'd say X min is probably 0. X max, okay, you could go up to 30. Okay, I mean, it's just once you get around 27, 28 in there, you're going to be in negative numbers. And a good way to scale that would probably be by tens. And then for the Y minimum 0 is logical. And then Y max, you might do something like 3,500. It doesn't have to be that, but that's a pretty logical way to do that. And then Y scale, I'll try 500. Okay, now you got to come up with that by looking at the table of values. And then once you get that put in, then you should be able to get a good picture, and then you can figure out what the max is, okay? So I'm going to go ahead and get that set up. And let's see if that looks good. Okay, there we go. Does that make sense to everybody how I'm figuring out my window? Yes? No? Look at that table of values, okay? Don't use zoom fit and stuff like that. Just look at it and reason it out. And then you can sketch a graph kind of similar to that. And then we'll see what the maximum is then. Okay, so we want to get left bound. Want to get right bound. So what I'm getting on that is I'm basically getting a parabola that's kind of going through this. Now this is not a good graph, but just as a sketch, that would be about, looks like 13.75, 3,025. Okay, so what is the number of seconds it takes for it to reach the maximum height? What did I find? 13.75, right. This right here is seconds, and then so your answer to the problem, it would be 13.75 seconds for it to reach the maximum height, okay? And if you draw a sketch, you would again need to label the X and Y axis a little bit more accurately like that, okay? All right, so those are the things you want to know how to do. Number 22 is slightly different, so I do want to go through that one as well. And then there's a few things we want to finish up with average rate of change is the other thing in this section we want to know. Okay, so with this one, let's put in Y1, let's put in 384 minus 16t to the second. And then the question on this one, it says, how many seconds will it take for the rock to hit the ground? So there's something a little bit different that you have to do on this one. I'll show you a couple of ways to do this then. Let me get this set up. And let's see, then we'll kind of look at a window. So this one I think is going to start at 384, and then it's going to follow a parabola down towards the ground, kind of like that. Okay, well, let's look at kind of a window on this. Now, if you go through it like this, you go second table, second graph. If you go through and look at this now, all you got to do is kind of start with 0. So I'm going to scroll back up to 0, and you're looking for positive y values, and eventually it's going to be negative, okay? All right, and this is what students ask me all the time, like during a test. They bring up their calculator and they say, how come no graph's coming out? Well, that's what you got to figure out, is how to get that window. So look at these numbers right here, okay? They start getting negative a little bit past 4. So to me, it would be logical to go maybe 0 to 5 or 6, but since we're going to find when it reaches the ground, you probably want to include some of those negative numbers so that you can do this correctly. So what I'm going to have you do is this. I'll put the window in and I'll show you kind of what I want you to do. I'm going to go like 0 to 6 because I want to go a little bit beyond where it reaches the ground, scale of 1. And let's see, let's do the y-min, let's use a negative number on that. Let's use something like negative 50. Let's see, I already kind of lost what those numbers were, so let me look at that real quick. So they were pretty big, like looks like maybe 400. Let's try something like this, okay? Because you want to get a really good picture of how this goes. So let's go for the y's, let's go negative 100 to 400. And then scale that by 100. And I'll explain why I'm doing that, because you're going to find when it reaches the ground, you have to use what's called a 0 command on your calculator. So if you put that window in, that's what I'm wanting to see. Now, we don't estimate that. We're going to get what that is precisely, okay? So if you don't know how to do this, if you've never done this before, you also want to write these keystrokes down because they're a little bit different. So once you get your graph, you would want to go second trace, to get this to open up. And what we're going to do is there's a command on there that's called 0. And what that'll do is that'll help you find the y-intercept or the x-intercept. Okay, so you want to do that. That's the reason why I took the graph out a little bit further than where it hit the ground. So you just type enter there, and then it's going to ask for a left and right bound. So when you're doing a left bound, you just kind of get into there fairly close. That's even close enough right there. Then you can press enter. Right bound, just get a little bit to the right of where that crosses the x-axis. Like that's good. And then once it says guess, type enter, and then it'll give you what that 0 is. You're going to know you did that right because that should say y equals 0, or it should be like 0.001 or something like that. So that's what that is. So what you get with this point then is if you look at this graph that I have here, what I found with my technology is I found that point right there is, and if I round that off, that's like I'm just going to say 4.9, comma 0 like that. Okay, so what is the significance of 4.9? What does that tell you? That's when it reached the ground. Okay, the 0 means it reached the ground because the height is 0. Okay, so that's kind of a good sketch of a graph like that. So then the answer to that would just be approximately 4.9 seconds to reach the ground. So that's another variety of this problem that you want to do. These are basically physics problems that you learn how to do in a Calc 1 class, okay, and in basic physics. Okay, so if you need to write down those keystrokes for how to find a 0, then do that. One of the things you want to do is use that command. Don't just estimate. Use that 0 command so it gets it precise. Okay, so that's important. Okay, everybody got that okay? Okay, so you'll use that also for finding x-intercepts, okay? Okay, so the last thing I want to look at on here, we want to work a little bit with average rate of change, and this will be kind of the last thing that we're going to have in this section. So we haven't talked about this yet. So what you end up getting on average rate of change is basically the average rate of a change is the slope of a secant line. And a secant line just means there's 2 points somewhere on the function. Okay, you know how to find slope. We've talked about how to find slope. So if you're asked for an average rate of change, you're looking at 2 points on the function, calculating the slope of the line that connects those. We call that a secant line. So that's supposed to say average rate of change is equal to the slope of the secant line. And of course, the formula for that we've learned is y2 minus y1 over x2 minus x1. Okay? So it's really a slope is what you're doing on this then. Okay? So I'm going to run through a couple of illustrations of this then. And what we want to go ahead and do on this is I'm giving you a function. Now I haven't given you 2 points, but I have given you what x is and what another x value is, like that. So what you want to do, you want to start off by finding f of 1. If x is equal to 1, you want to go ahead and just plug into your function and find that y value. So that would just be 1 to the third minus 1. So that's 1 minus 1 is 0. So that means you would get a point, 1, 0. Okay, so when x is 1, y is 0. So that's a point that will be on the graph. Okay. Then we want to do the same thing for x equals 2. So what you want to do is you want to do f of 2. So again, plug the 2 into your function. So you're going to have 2 to the third, then minus 2. That'll give you your y value. So that's going to be 8 minus 2, which is equal to 6. So that tells you that when x is 2, y is 6, like that. So the whole key to the problem before you find average rate of change is get 2 points. And I have to give you the x values. If I don't give that, you couldn't do anything. So now what you do when you do the average rate of change is you just find the slope. Okay, so what we're going to do on this is, remember, you subtract the y values, so you have 0 and 6. And you can do it in either order. Just pick the order. And then subtract the x's in the same order. So again, that's given a rise over a run, like that. Okay, so we're just doing a slope between 2 points. That means the average rate of change would be 6 over 2, so that would be equal to 3. Okay, what that means is between those 2 points, you have a positive slope, so that means that's sloping upwards like that. Okay? All right, does that make sense, what I did? You're looking at me funny, so I must have made something, done something wrong there. What did I do wrong? Oh, 2 minus 1 is not 2, class. What is it? I believe it's 1. Thank you. Okay, let me correct that then. Just checking. All right, so we got 2 minus 1 is 1. So now we have 6. Is that better? Okay. All right, you never do anything like that, I know. All right, so that's the idea. So if you're doing average rate of change, you want to just look at 2 points on the graph and then be able to calculate that slope. That's the idea. Okay? Now, get your calculator out. I want to do one little thing with this problem. I just want to explain one thing about this. And we're going to do this in just probably a standard window. So we're going to put in y1, let's put in x to the third, and then minus x. And then this time, let's just do this in like, let's actually do this window. Let's start with, just go standard window. So just go zoom 6, and then you'll have a cubic function like that. So actually what we did on this is, and I'm going to zoom in on this. I just started in a standard window. Then I'm going to go option 2 and zoom in, just because I want to zoom around that area there a little bit. Okay, and then I just want to show you, you don't have to draw this graph or anything, but I do want to show you what we really did in this problem. Let me clear off one of those things. Okay, so really what happened on this problem is this. On your graph, what you had is we have a point 1, 0. That's that point right there. And then up here somewhere, you have a point, and I'm just kind of estimating 2, 6 like that. So what you really did is you found the slope of the line that connects those 2 points. That's what that is. That's called the secant line. Just means up 6 over 1 is what the slope is. Okay? Does that make sense? You don't need to draw that graph. I just want you to know what you're doing when you do average rate of change. Okay? All right, any questions? Okay. All right, let's take a look at this one. This is one that you're not given a function, but you're given a table of values on this. So what this one says is these are the different months. April starts with x equals 1, and then they're just going to get bigger, 2, 3, 4, 5, 6, 7, 8, 9. So basically we're starting at April and just using x equals 1 for that then. Okay, and then we have stock prices. So it says find the monthly average rate of change between June and September. So really all you do is you just locate that point, and you locate that point, and then you find the slope. Okay, so your points are going to be, June is going to be, we're going to use 3 for June, because April starts with 1, and just count from there. Then we'd have 88. Okay, then September, we're going to start with, let's see, that's 6, and then go 111. So if you want to find the average rate of change, what are you going to do? You're going to find the slope between those 2 points. Okay, so it's just y2 minus y1 over x2 minus x1 is your slope formula. So you would do 111 minus 88, and then you would do 6 minus 3. Okay, and we might use a decimal on this. We'll just see how it turns out. So 111 minus 88 is 23 over 3 like that. Now we're talking about price, so it's probably a good idea on this to go ahead and just change this to a decimal. So if I do 23 divided by 3, that would round to about 7.67 would be approximately average rate of change. So that's the idea. So you don't have to be given a function necessarily. You can be given pieces of data and figure that out the same way. So that's the idea, okay? All right, so that's kind of the end of where 3.3 is. This section, you want to know how to do average rate of change, maxes, mins, decrease, increasing. There's a lot of technology stuff in this section, and that'll be as far as our first exam goes, okay? So everybody did get the review. Be sure you bring your review to the recitation, because probably the next couple of classes you'll probably need to be working on getting ready for that test, okay? All right, and I'll let you out a little bit early tonight because I don't really want to do much with the next section until next time, okay?